All right, everybody, ZAPCon 2022. It's time for the keynote. I'm super excited about this. Hang in there with us. Jim Manico is the founder of Manico Security, where he trains software developers on secure coding and security engineering. He's also an investor advisor for 10 Security, MergeBase, Nucleus Security, Bit Discovery, KSOC, and Inspective. Jim is a frequent speaker on secure software practices and is a member of the Java. Wow. Early morning for me. Is a member of the Java champion community and is the author of Ironclad Java, Building Secure Web Applications from Oracle Press. It's my distinct pleasure to welcome Jim Manico. Jim, let's do this thing.
Scott, thank you so much. I'm so glad to be here. Scott, I get really excited about building application security content. So I have a couple extra slides for this keynote. This is about 140 slides. I'm going to go real fast. So I have like 3 hours to give this talk. Is that right, Scott? No, I have 40 minutes. I'm going to do it anyway. So let's do this. Let's do this Manico style, 140 slides, 39 minutes. Are you ready? Let's do this. Let's talk about the OWASP Top 10 and let's talk about Zap. So the OWASP Top 10 is built by Andrew Vanderstock, Neil Smithline, Torsten Giggler, and Brian Glass, data scientist. I'm a huge fan of this awareness list. It's great for education. It's great for conference talks. It's great to bring people into the OWASP fold and teach them about application security. And 8 of these items are picked from data science, primarily Brian Glass from data collection. 2 of these items are picked from community voting because data is not always going to give you the answer you want. I know it's hard to hear. Data is not always the full truth. Sometimes we need instinct from our professionals in our community. So again, 8 of these are data-centric. 2 of them are community votes. The first one's access control. Broken access control has been around since the 70s. Principle of least privilege from Salter and Schroeder. And we see the most applications from our data study at the OWASP Top 10 that shows that truly access control is the biggest problem we face in modern security. And this is because, it's really difficult for most turnkey DAS tools to address access control, right? Zap doesn't have that problem. We'll get to that in a second. But access control is really difficult to test from automated tools because unless you're configuring them, your scanning tools are just not aware of access control policies. It's custom in the business logic domain. And very often the frameworks we have for access control, they don't handle detailed access control functionality. The key here, vulnerability, is indirect object reference. This is one of the biggest problems when it comes to access control because I just change a number and I'm changing the query and stealing data. So in some way, we need to add the data-specific access control check in our software, and there's no standard way to do this. I'm doing it at the data layer. You can do it at the application layer. You may have a special framework for access control. You're probably building your own enterprise framework for access control, and that fragility brings access control to the top of our list when it comes to the OWASP Top 10. So some things I recommend are when you're designing access control, stop hard coding roles, hard code a feature. The feature names. Java calls it permission. .NET calls it a capability. The U.S. federal government NIST standards calls it attributes. Whatever. Stop hard coding your policy. Stop hard coding roles. Some other design issues are things like implement a standard data-specific access control layer, build it centrally, make sure all your requests go through an access control layer, deny by default if things go wrong, use the right server-side data to drive your policy. Make sure if you're changing configuration from a user, takes effect right away, even if they're logged in. Have proper grouping in your data model and build your admin screens first. Once you can manage that policy metadata, the rest is straightforward. In the OWASP Asvs standard, we have a lot of great requirements here. And you'll see that Zap does a really good job at addressing a lot of these very specifically. So I like you to read the authorization cheat sheet from the cheat sheet series. NIST 800-162 is stellar. This is the attribute-based access control standard from NIST for North American countries, but whatever. It's a good document regardless. And there are the ASVS requirements. Now, let's put some Zap in this, right? So what is Zap addressing? They're addressing so many different access control category issues, but more importantly, and that's going to be limited, right? Any automated scan, is not going to know your policy. That's why there's a whole access control testing methodology add-on for Zap. So you can configure your policy into your scanner so you can actually pick up understanding of your specific policy, something that a turnkey scanner is not going to be aware of. So this is a real mature approach to addressing access control from a DAS scanner. That's why we're here. That's why we love Zap. 2, the OWASP Top 10 2 cryptographic failure. This has been brought up to position number 2, and it's the successor to sensitive data exposure. Data exposure is the problem, but the root cause is some kind of broken crypto. Use TLS everywhere. Go ahead, fight me on this. TLS everywhere. There's no excuse not to use TLS. Damn it, Simon. We all know this. Use TLS everywhere. Use it well configured, and consider additional mechanisms like strict transport security and preloading of strict transport security, and 100 other configuration guides you can look at to really lock down your TLS. Also with crypto, we got to get key lifecycle right. AWS and Azure specifically have really mature key management capabilities. Like I had to build this from scratch, huge heavy duty resources. In Azure, I can go click, 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 and I got good key management. Got to pay for it. But that's why the cloud is really improving things. The cloud is improving things. Things like difficult key management and data storage with crypto, it's turnkey and only getting more turnkey. Yeah, so I love the cloud. A big part of secrets management is key isolation. If you can extract a key from a key vault and use it, you're really missing the point. We want our critical top-level key encrypting keys to be in hardware and not be extractable. That's one of the key areas of getting secrets management correct. And I love what we see at Cash App here. We have a KMS key that never leaves the vault that encrypts service-level keys for each app that then encrypts data-level keys for individual data encryption needs. And why I like this is because I'm encrypting one major key per department at the KMS level, and I have a key hierarchy, so I can do key rotation on demand for data keys whenever I want for service keys. And the KMS key is hard to rotate. I do that when I'm able to access every key from every major app. But there's a lot of capability that's getting close to turnkey that was really advanced in the past is now a service for us in the future. I love it. The cloud will save us all. Google Tink turnkey library that does apply crypto in a real solid way. In fact, Cash App, when they published this article, they're using the KMS in Amazon along with Google Tink, which integrates with it. This is a real powerful combination. Libsodium at the C level, awesome crypto library. Here's a few of our guides: TLS cheat sheet, SSL Labs, the OSAF project from OWASP Germany, and Test SSL. These are scanners for TLS to check your config that it's even okay for intranet apps. I love SSL Labs, the de facto standard for internet-facing apps when it comes to TLS scanning, and of course the cryptographic storage cheat sheet. Let's zap it, right? So there's Oracle padding attack scanning. There's TLS scanning in various ways. There's weak authentication. The authentication issues, they flow to a lot of different categories in the top 10. We'll let it go. So we got some crypto built in to our great tool Zap as part of our dynamic scanning capability. A3 injection, SQL injection, right? And so we've known about this since 1998. Jeff Forrestal, Usenext meeting, Christmas Day, used the term SQL injection for the first time in Frac magazine, right? 94% of apps have injection. We understand how to fix this pretty well at this point. We even merge cross-site scripting into injection, a topic we know how to defend against well. Super complicated, but we have the knowledge of how to do so. With SQL injection, you're adding data into a database query, just like this. When you see string concatenation, let's get the pen out. When you see string concatenation in a SQL query, that's always problematic. We usually want to avoid that all around. And so how do you stop SQL injection? You validate? No, damn it. You're not going to validate and save this problem. This is a valid email address. It's every standard, the main email standard, the 2009 rewrite, the HTML5 definition of an email address. They call this a legal email address. That regex has a lot of characters in the HTML5 standard for email addresses. It's a problem. So even valid data can cause injection. Sing it with me right now. even valid data can cause injection. I said, sing it. Even valid data can cause injection. Whatever. Bad voice. I'm not tuned. Let's get to work here, damn it. We do the query. We add this valid but vulnerable email address to the query. And this is the final query when we do string concatenation. Or one does not equal Manico. That's always true. You add or true, you drop the where clause. I got the whole table with the valid email address because you depended on validation, damn it, Simon. We know better. We do want to do validation, but the real answer here is to always parameterize your queries, right? It's a real simple programming construct. It's a performance pattern as well. You can't always parameterize like a column name. Use strict validation. There's an exception to this rule. Go take a look at Bobby Tables and the query parameterization cheat sheet that talks about how to stop SQL injection. We also want to stop cross-site scripting, which is when untrusted data is added to a UI without any protection. That's great site, but now I can modify that content, right? Evil script, you click on my link, you're executing my evil script, cross-site scripting, right? Basic, that's reflective. Reflective, I send a link, you click on it, I execute the payload, I steal your data, game over, cats and dogs living together. It's a catastrophe. Stored, I'm implanting that attack in your database. Then you go visit some feature that retrieves that data in an unencoded, unsanitized way. We got cross-site scripting, stealing data, and many others. There's a cross-site scripting payload where if I get this attack to land in a victim's browser, we steal their cookie and then send it to another website without the user even seeing anything. There's many other attack examples. I'm not going to go through a lot of them. I'll just do one. We'll do one. So the New England Patriots is an American football team that's a disgrace on our country. They're lying, cheating, dishonorable team. And any other team is totally awesome in the NFL. And I loop through this a lot to let people know that the New England Patriots, they're full of lying cheaters because they are. And then I say document body inner HTML and overwrite the whole body with this truth about American football. But it's way more complicated than that. It's so many different layers we need to know to get cross-site scripting right. I really think content security policy is a key defense here. So let's zap it. Now, okay, let's talk about zap and injection for a second. You ready? Here's page 1, SQL injection, cross-site scripting, all kinds of even expression language injection and LDAP injection and out-of-band XSS. You got some soap. Who does soap anymore? We got all these soap attack payloads and hypersonics. What the heck is hypersonic SQL? I have no idea what that is. It just sounds really awesome. Here's all these vendor-specific SQL injection payloads. Oh, we're not done, Simon. We got some user controllable JavaScript events. We got some XSLT injection, old school. We even have there's the eval villain and the fuzzer to aid with injection, a little more detail with manual. So injection's been around for a while. Zap is hardcore at finding dozens of different kinds of injection. Very impressive. A4, insecure design threat modeling has made its way to the OWASP top 10. I'm a little bit of a on threat modeling, but there's so many problems in software that we're not going to find just by scanning. No, I mean to hurt anybody. I love Zap. I use Zap and I need Zap, but sometimes we have to actually think about writing the software from a security perspective before we write it, right? And so I'm a big fan of Avi Duglin. This is Avi Duglin's presentation on threat modeling. He teaches for me. It's someone I'm a fan of. I like his developer-centric methodologies. Let's put some Zap into this. So these are some of the design type issues that Zap is going to discover, right? Things like missing crypto or misuse of crypto or improper view states and weird parameter tampering. These are just samples that it's not like a direct vulnerability per se, but these are symptoms that we have deeper design flaws in our software. Go Zap. A5 security misconfiguration. This is a big deal of a category because of our mass migration to the cloud, which I'm a big fan of. We have a chance for better security, application security in the future because of the cloud. I'm a big fan, right? Things are standardizing there as well. It's part of the current wave of software development. Anyways, misconfiguration addresses this, but at some level, I don't like this OWASP top 10 category. And bear with me. This is because the topic can really span anything: password length, file permission, and access control, and more. You got to read the manual, understand the entire framework and deployment environment, everything in between, to really understand security configuration. You have to know your framework, libraries, and your production environment, and have expertise in all of those areas. A good place to start is getting hardening guides for the components and services that you're using, and actually run through it and vet it by an expert. When you're doing proper configuration, again, every major framework has a series of hardening guides. Get your AppSec people to vet them, or maybe even build a golden image for your team that you can reuse over and over. And here's SSL configuration generator from Mozilla. We have meta configuration layers now, like Spring Boot to help configure Spring, to help do Spring security. We got the Mozilla SSL configuration generator to help us generate our TLS config for all the major environments out there. I use this for my server. I'm getting A+ on my server because everyone looks at it and pokes at me, right? That's all good. And so security misconfiguration. If you can't verify the config, assume it's not secure. Read the manual, understand hardening guides, get expertise for your platforms. You need it. Let's put some Zap into this, right? So Zap has got, I've given up on like 5 or 6 slides now. Zap has a whole bunch of things it scans for that's addressed by proper configuration. This is really a thorough category. And you know what? As an educator, I focus on defense mostly. As I was building this presentation, going through all the different dynamic tests that Zap does, it helped me identify some gaps in my own training of things I should be talking about. This is really thorough in terms of what Zap is looking for in the manual and automated scanning capabilities. When it comes to configuration management, though, again, access control testing could help here. The compare with another session capability, manual capability may help as well. You got the Ajax and other spiders. So all of these manual and automated capabilities help in this configuration category. All right, we're looking at A6, vulnerable and outdated components. We're about 20 minutes out, right? I really believe this should not be the 6th category. Vulnerable and outdated components. Once we saw all the data from the Log4Shell, Log4j incident, if we included the Log4j data call into the OWASP top 10 data call, third-party library problems, vulnerable and outdated components would have easily been number 1. And so this is my number 1, even though it's number 6. This is my number 1. It's managing third-party components. This is bleeped up how much companies struggle with this issue, because we have so much legacy debt in most big companies. We're using so many old libraries with the minimal will to update them because of how difficult the problem is. And if you solve the problem and update your libraries and have process where you keep updating your libraries, that's a huge thrash for an unknown security benefit. So it's like no one wants to deal with this, but we have to. And so the race is on to patch Log4Shell. We're past that, but it brought awareness to this issue yet again, that third-party libraries are bleeped up. Beginning of 2001, I saw major vulnerabilities in WordPress is what we're looking at here. One of the most popular web development software packages in the world. It's garbage from a security point of view, in my opinion, but it's everywhere. And we saw major critical exploitable vulnerabilities in WordPress because of a third-party library that was doing XML parsing. And here's Drupal, one of the second biggest content management systems in the world. Critical vulnerability, early 2021, again, because of a tar library that they're using. This is nuts. So my answer is to stop using third-party libraries. No, that's not realistic. That's not realistic. I want to nod to another OWASP project that's in our flagship category, a sister project to Zap, that's OWASP Dependency Check. Look, the main business that competes with Dependency Check is a $6 billion plus business. So this is a really important open source tool to give you initial enterprise capability to look at third-party library security. I also use retire.js a lot. It's a plugin to Chrome that identifies insecure third-party JavaScript libraries. And Dependabot, you know what? Everyone, oh, I love Dependabot. Dependabot is really screwy. I'm sorry. I don't like Dependabot. It makes a lot of mistakes and is really noisy. And yet everyone says how great Dependabot is. But I'm giving a talk in 2 weeks about the shame of Dependabot and why it's something we can't depend upon for dependency management. Even though it's an interesting tool, it's way more, everyone says it's so great. I'm here to tell you it's not. And so I like dependency check and SCA scanners, software composition analysis scanners, a lot better. Check out dependency check. Also, Zap, let's put some Zap. Zap covers this. Zap is looking at a lot of the really critical global third-party library events like Heartbleed and OpenSSL, Log4Shell, one of the most intense vulnerabilities in all of history, shell shock in your bash scripts. So Zap is covering some specific high-level problems, and there's even a neat technology detection add-on that will help in this area as well. I think using Zap as a dynamic scanner along with dependency check as your code scanner is a really great combination of flagship projects working together at the OWASP Foundation, but Zap certainly addresses this as well. So let's talk about A7. This is the OWASP Top 10 identification and authentication failure topic, right? And so A7 is really important. This was previously broken authentication, and it slides down to second position. We see this in both the community vote and in the data call. The reason why this topic, identity, slid down so much in the OWASP Top 10 is because more and more we see standardized frameworks and identity providers that to some degree solve this problem for us. It's less and less the case where we're building authentication layers from scratch. We're leveraging frameworks and components for this a lot more than we did in the past. Back to the beginning, what's authentication? We're just verifying identity of a certain entity, right? We want to know that a script or a service or a person is who they claim to be. An authenticated session is how we track a user typically after they log in. That's what I mean by an authenticated session. You're either using a session ID, traditional session management on the web, or you're using a JSON web token if you're a hipster with microservices and you got to use the latest technology. I see a lot of JWTs misused when we don't need them. My preferred pattern is the backend for front end pattern, where I combine these, where I have a session ID between the user and a gateway, and the gateway will translate that active session to a JSON web token, which is used in the backend to access services. I love BFF, backend front end pattern. I digress. Authentication is a brutally complicated topic. There are so many things to scan for and so many problems that we can discover when looking at authentication layers. It's also a business logic domain, which makes it tricky to assess because a lot of this is custom to our app. The other difficulty we have is, well, how strong should the identity be? How strong should our login system be? And I love Daniel Miessler's consumer authentication strength maturity model. Let's talk about this in the language of NIST 863B. That's the digital media identity standard for U.S. government in North America with the National Institute of Standards. And they define 3 different levels of assurance, right, for authentication. They say AAL level 1 when you don't have sensitive data, when it's not that sensitive of an app. AAL level 2 is really the baseline for sensitive data-based apps. And AAL level 3, this is like multi-factor with a YubiKey or smart card or cryptographic certificate for infrastructure type apps. AAL level 2 demands multi-factor that's SMS plus something else. And AAL level 1 is like password by itself is okay. If we look at Daniel's consumer authentication strength maturity model, Daniel Miessler, one of my favorite security pros out there, right? And so what do we got for Daniel? At AAL level 1, AAL level 1, we're juggling passwords. And the best of breed is to use a password manager. But even password manager-based passwords alone, they're vulnerable to account type takeover attacks. Quality passwords are vulnerable to password dumps and password cracking. I can live guess a unique password if it's not strong. I can credential stuff you if you're doing shared passwords. At AAL level 2, we're doing multi-factor with the number, AAL level 2. Some kind of new number is sent to you from an app or from SMS or similar. This is all AAL level 2. Daniel, I don't like passwordless is a horrible term. Passwordless authentication as a term drives me nuts, and it's pushing us towards really weird, unprotected, I don't think valid solutions. So AAL level 3 is not asking for passwordless BS. That's Apple infecting Daniel's brain. The first version talked about this as cryptographic certificate verification, where I have to use I have to use some kind of dedicated YubiKey or a dedicated smart card or other strong authentication. That's what A3 really means. That's what Daniel said in his first publication. I think Apple got to him, made him say passwordless. It's okay, Daniel. We love you, Daniel. This is a great guide in terms of how to address how strong your authentication mechanism should be. And this is the workflow for NIST 863, right? The point I'm trying to make here is, let's say the only risk is low for leaking of sensitive data, and there's no other risk that we're worried about. Do you assess high for any of these? No. Are you moderate for any? Personal safety? No. Are you moderate? No, I'm not moderate. We know that already. And are you low for unauthorized release of sensitive data? Why, yes, we are. We should use multi-factor. The point is, according to NIST standards, if you have sensitive data in your app and you're not doing SMS multi-factor plus a stronger factor, if you're going to support SMS, then you're not compliant to basic US government standards. And I like this. There's no excuse not to offer multi-factor. If your service is password only, if your web app is password only for authentication, you're like 20 years behind the 8 ball. Get some multi-factor on that, damn it. I'm watching. I want multi-factor. Also, password policy has changed a lot. Let's take a look. Let me jump ahead here a bit. So I want to take a look at, as for a password scheme, the same standard, NIST Special Publication 863B. And they're recommending a whole different approach to passwords that I find to be fascinating because it's so new. Don't limit the type of passwords, 8-character minimum, 64-character max, but no more than 128, right? You got to support up to 64, but stop at 128. Force MFA anytime sensitive data is in play. That's a poem. Force the use of MFA anytime data that's sensitive is in play. That's right. So this 8-character limit, put that in the context of you got to have multi-factor. If you don't have multi-factor, go implement it right now. We'll wait for you. So check against a list of common passwords and a list of breached passwords, right? These are two separate block lists to build. Throttle brute force, stop the special character rules. Very controversial. But if everything else is in play, it makes sense. Stop the security questions. I'll look it up in your Facebook account. And no more password expiration for the sake of it. These are the new rules of password for NIST. And this is not a good password for several reasons. It's ultra common. It's like 32,000th most common password used. It's in breaches, and there's a pattern. There's the word password in the middle, a context word we should avoid. I digress. If you're still storing passwords, just one more for fun. You really should be using Argon 2i. And by the way, bcrypt for password storage is crap. Please stop using it. I'm supposed to say it. I'm supposed to love bcrypt because the whole cryptographic community is BFF with bcrypt. Oh, but it's crap. It truncates at 72 bytes, unlike every other password storage algorithm. And it uses very little memory, and it's got crackability. Don't use it. Get away from it. Instead, use Argon 2i. Use Scrypt if you must. Or if you're FIPS for compliant for federal government in the US, PBKDF2 is the main standard there. Go check out the password storage cheat sheet. Rip out the cryptographic garbage that is bcrypt and use a real algorithm for password storage. like Argon 2 ID. Made for it from the ground up, baby. So to learn more about this, here's the ASVS requirements for authentication and session management. Here's NIST 863. If you're an identity architect or team lead or similar, you really want to read 863, Digital Media for U.S. Government and North American Countries. Outstanding document. Let's zap it up. So what do we see at A7? Sessions. This is all manual aid tools built into Zap. Manual Spider, you got the Force browser, you can do token generation. And again, access control testing in general helps in this layer. All right. How's everyone doing? We're nearing the end of our keynote for today. We got 2 more categories as we wind down here, right? Where are we going? A8, software and data integrity failures. This is a new category for the OWASP Top 10 this year. This addresses a lot of different areas. The place where this is critical to me in my work is that I just think about how many times I download a script into my DevOps pipeline and execute and run it. I do that a lot from all these different DevOps services now. And what I realized is I'm not doing enough integrity checking. So I got to, my belief when I went back to address this issue, when I realized how big the problem was, deserialization is a part of this category. I'm not going to address it. We've covered it for years. But I believe when it comes to running scripts from your providers, always aim for the rule of 2, right? Santa Claus checks his list not once, but twice. Don't ask Santa. It's all right. So I am always I'm always wary of a script that I have to download and run daily. That's becoming a lot in many DevOps pipelines. So I'll start by verifying that script once via the download hash, but that's not enough. And I'm going to verify that script a second time by comparing it. By comparing it against the published repo for that particular script. Most DevOps service providers are going to publish their script in GitHub and give you access to it. So you want to see if both of these match. Did the download hash match? Did the publish repo match what I'm trying to run here? Because usually attackers will compromise one of these things. They'll either compromise your GitHub repo or they'll compromise your deployment. And by doing the rule of 2 for checking the integrity of your scripts that you're running for providers, you'll minimize the potential of this happening. It's the best I got. It's a big problem. And there's a lot of other aspects to software integrity. Zap addresses a few issues in this area, right? Got loosely scoped cookies and cross-domain JavaScript source file inclusion. Oh yeah, let's go take a look at A9 now, logging and monitoring. I like this category, even though I don't know of any app that was hacked because of logs. Oh wait, that's not true anymore. Yeah, I take that back. I meant to say that the world's Java logging infrastructure has been remote code execution compromised because of a logging library. Oops, nobody saw that coming. I swear, nobody saw that coming. Did anyone think that a logging library would lead to the application security apocalypse? No, you didn't. But that's not why we're here talking about logging. The goal of logging is to alert on specific security events. Every other logging need is secondary. Compliance, yeah, get my fiddle. Here's my compliance fiddle. I don't care about compliance. I don't. I care about security. Sorry. Forgive me. Don't hire me to do compliance review. I'll say, we're done. I don't care. Okay, so the goal of logging is to alert on specific security events. That's the whole point of logging, to give you early intel that you indeed are being hacked. So who's watching your logs? First of all, when I look at how big companies work, more often than not, they're not even like intaking app level logs properly. And in order to do that, your SOC teams need standardized security events. They need to understand what is and what is not normal. At the cheat sheet series, we have this new cheat sheet that was donated from Nike Corporation and Jet. Thank you, Jet. So went through legal. This is now an open source guide. It shows all the different logging events that you should consider when building a logging strategy, when doing security logging. And be careful here. Like, we want to make sure we're both logging good security events, but also not logging certain data in relation to GDPR and other privacy law, right? Zap's got a whole suite of manual test capabilities to address that issue. A10, we're done. Server-side request forgery. This got brought into the OWASP top 10 purely from the community survey. At the time we're doing the study, not a lot of tools can assess this well. It's a hard problem because it's deep in n-tiered architectures where this problem is weaponized. We saw Capital One get popped by this really bad because they had a parameter that their server acted upon and made and requested and fetched that piece of data. And this parameter was not validated. This app was in AWS, and they changed the parameter to be the WAF's credential file, and that's what was returned in the web page. This is a server-side include, and it's when a parameter is sent to a server, and the server acts on that parameter or data in some way. We've seen SSRF at GitLab. We've seen it at Microsoft Exchange all in the last year. And this is a common way of attacking your microservice or REST architecture. I send data to a public endpoint. That data is added to a URL to do the fetch at B. And now I got path traversal so I can steal different resources if there's poor authentication and access control at that backend server. And so, again, the attack is a form of path traversal usually, where I can change the path and now go steal admin resources when I don't have access to do so. And the solution here is usually you want to escape a parameter or encode it before you add it to a URL. So path traversal is not possible. I also think you want to have great authentication and access control on your backend APIs. Do strong validation of any parameter that's a URL that your server acts on. You can even put network controls around your services and microsegmentation to limit what resources they can fetch in the first place. If you're going to build a URL, do it safely with proper escaping and encoding of parameters that you add to a URL that are attainable by a user. Let's zap it up. Out-of-band security testing, non-trivial solution to a very non-trivial problem. Rock on Zap. Let's finish up with this. Please go take a look at the ASVS standard and the cheat sheet series for more information on secure coding. Please go take a look at Zap and dependency check as great tools for testing, as well as the testing guide to augment your knowledge. If you want a copy of this 140-slide presentation, go to tinyurl.com, OWASP Top 10 Zap. And all 140 slides are there for you. With 3 minutes to I'm done. 140 slides.
Dude.
That's
like a lightning talk with more than lightning. I don't know. People were in the Discord loving what's going on here, Jim. So I know it's hard to get feedback on some of these virtual talks, but people were loving what you had here. And this last slide is very appropriate because people are asking for it. So being able to download that talk. Hey, one quick thing. I forgot to run this at the beginning. So it's really cool. 1 second here. All right, Jim, thank you so much for doing our keynote talk today. It was super good content, amazing talk. Real quick, the Zap core team and Simon was taking a lot of brunt of what you're talking about here. So I would be remiss if I didn't mention that there's a Retire.js plugin for Zap. So you were saying you use Retire.js browser?
Love it.
There's a plugin for Zap. So there's that.
That's outstanding, Simon. Thank you for that.
Thank you, Jim, for your talk today. I know we're kind of short on time here. As a reminder for everyone, this is going to be recorded. You can rewatch it. You can hit the pause button. You can play it at 0.25, so it's like normal speed if you want. Jim ripped through all this content, which is amazing. You can also hit the pause button, check out all those resources. Jim, I know you got a busy day today, so I want to thank you very much for joining us for ZAPCon 22, doing amazing keynote speech. Thank you, everyone that wants to go hang out, follow Jim on Twitter. It's at Manicode. He's fun to follow as well. Jim, thank you.
Thank you to the entire Zap team for all your hard work in building this critical open source assessment tool. Thank you for your hard work, everyone. Take care. Bye-bye for now.